Hello, Stormwater designers. Welcome back to Clear Creek Solutions hydrology education videos. We're getting back into more of the hydrology education related to continuous simulation and water sustainability. We've also been talking about some of the big water resources problems that are going on right now, some of the possible solutions and fixes to these problems in the modern day. And so that's what we're going to go over here. We're going to talk about how continuous simulation is going to help make the world a better place in terms of helping the water management, pollution management of our rivers and streams, and overall improve the use of our water resources, which is incredibly important heading into the future here as the population continues to grow, and proper management of our water and our water resources and keeping that supply clean is going to become incredibly paramount. So Clear Creek Solutions, as you probably know, provides a complete range of hydrologic services. We specialize in continuous simulation modeling and have 40 plus years of experience between those founding members. We created WWHM 2012, WWHM-SWMM, and then educational packages for that software to teach stormwater engineers how to design water resources designs in continuous simulation software in those jurisdictions. Now let's get into the video here. We're going to talk about the big pollution problem. And so just close your eyes for a second. When you think of pollution in our water or our streams, what immediately comes to mind? And this might surprise you with the result here on the next slide. But when we often talk about pollution in water resources, we often think about, there's an oil spill, a gas spill, or some sort of chemical got in the water and it's causing a problem. And it needs to be filtered out, it needs to go to a treatment plant. Sometimes this is the case. But a lot of the pollution problems that we're going to be experiencing with our streams and rivers does not come in the form that you would think of. And so, like I said, you probably imagine something like this. We've got a bunch of trash in a lake. We've got, pollutants and oil, and the water is just completely ruined, and it's going to require extensive cleaning to figure out and to get it back into shape. And so you might picture this, but I want to really open up to you another idea or something else that is causing pollution in our streams, and it's actually more of a natural occurring pollution, but it's caused by unnatural processes. So there's actually a bigger pollution problem that we're not quite always talking about, and it doesn't always get much of the press, but it's incredibly important to realize, to understand, and to discuss. And this is why continuous simulation is going to be the solution to this problem. But let's look at this stream here. What do you see as the big problem with this stream? You probably see lots and lots of erosion. And so erosion is a natural occurring process where the water eventually is going to erode certain substances down, whether it's rock or soil, and some of that sediment is going to end up in the streams. And a natural amount of erosion is fine. It's been a part of natural processes for a very long time. But it's when we begin to multiply the amount of flow and have more water in our system due to impervious surfaces that this pollution starts to become an issue, because too much of it begins to accumulate in the streams, and it begins to become a major problem when it comes to the water quality of our streams. So there's a bigger pollution problem, and this is one of the more likely occurring ones, and it occurs a lot of the time in these jurisdictions and across the country here. So let me explain what's going on. So pollution can occur in the form of actual pollutants, chemicals, hazardous waste material, or hazardous materials and waste, and any other one you dream of. But pollution can come in the form of excessive erosion in our streams. And so what is excessive erosion? So the erosion will increase the amount of small dirt particles in the stream, reducing the usability and quality of that water. And so let's think about a project site, or even more from a bigger picture. Just think about an acre of forest. When rainwater rains on this forest, some of it's going to some of it's going to end up in the leaves, some of it's going to infiltrate through the ground. Some of that water will run off, some of that will enter the groundwater, but it's a natural occurring process. The environment is set up to handle this amount of water. It's been doing it for a long time. We're going to get some flow from the project site, and some of it will erode the local streams and rivers, but that's been occurring for a long time. Now, if we cut down 0.9 of that 0.1 acres and we replaced it all with concrete and buildings, roofs, now that water is not infiltrating into the ground, it's running straight off because it's essentially impervious surfaces. That means the water can't penetrate through it and get into the ground. So now more of that water is running off the project site, and now we have greater flows coming from the project site, increasing the amount of erosion because we now have faster flows, they're occurring more frequently, and we have more volumes. Now we're getting more erosion, more sediment is ending up in our streams, and it's causing more problems as it relates to the pollution and the water quality of our streams. And so if we use improper design tactic to design our project sites when we add impervious area, we're going to end up with more and more of these erosive flows that are tough to undo if we don't create proper mitigation methods, proper facility sizing to account for these different erosive flows. And more importantly, it's not just about determining what a peak flow is from a site. It's about matching up the release of that flow properly to prevent this erosion from occurring. And this is what most of the pollution problems that we're going to experience in the future will come from. And there's a way to fix it. And so this is actually a national issue. So erosion control duration matching is only used in a handful of states in the entire nation. And so I have more videos about what WWHM 2012 does and what duration matching is. But essentially, we're trying to model when it rains, how many of those flows are exceeding that flow would have been like off the project site in the pre-developed scenario before those impervious surfaces were added. We model how that flow is done, the back-to-back events that occur, and the occurrences of those flows. And we try to match that with the mitigated flow or with a pre-developed flow in the mitigated scenario using continuous simulation modeling. However, that's only used in a handful of states. And so that means most of the water in the country is being mismanaged and mitigated improperly because they're using an older, outdated method called single event hydrology. And that's what's being used in most of the country right now, not properly modeling the release of flow causing these damaging erosive flows. And so how do we properly model the hydrologic cycle? And so these are the states that have implemented some continuous simulation modeling right now using our models. Here we got Washington, Oregon, California, and Texas. And not all the jurisdictions in those states are using continuous simulation modeling. So most of the country, a large portion of the country, or a strong majority, is not using methods like this to model their mitigation methods for their projects. And so most jurisdictions use single event hydrology. And this is a simple method of calculating peak flow from a project site using really simple equations, really outdated equations that don't properly model the hydrologic cycle. If you want to learn more about continuous versus single event hydrology, you can look at our YouTube channel. And this does not account for soil moisture conditions, back-to-back events, or flow frequency. The single event hydrology can account for how much moisture was in soil before the storm event, what back-to-back storm events will look like, and how that will contribute to the runoff, or the frequency of flows from the project site. It also cannot compute these erosive flows and the flow duration. So it can't account for these damaging erosive flows that are causing pollutions in our streams. They're not even accounting for that in these single event hydrology methods that are being used in most of the country. So how should hydrology be done? Well, continuous simulation hydrology uses historical rainfall data that has occurred in that region. So we can calculate back-to-back storm events and the soil moisture conditions that will occur from that project site, and then we can calculate the flow frequency to prevent erosive flows and allow the modeling of mitigation facilities such as detention ponds or LID facilities account for these erosive flows and prevent them and protect our streams and our wildlife in those streams. And this is better for water management, the quality of the water, and the sustainability. So what are the tools to use continuous simulation hydrology? These states use continuous simulation models to calculate the erosive flows. That was Washington, Oregon, California, and parts of Texas. And Clear Creek Solutions has developed numerous continuous simulation models, which include WWHM 2012, WWHM-SWMM, San Diego Hydrology Model, the Sacramento Area Hydrology Model, Salinas HM Trust, and many more models that we have used. You can visit our website to see. We have developed these models for these jurisdictions to help better these communities and better manage their water resources during these times where these resources are very crucial to properly manage. And so what are the benefits of these continuous simulation tools for our local jurisdiction or community? Well, it allows for better water management for that community. It can prevent flooding and the erosion in the streams, the damaging erosion, the unnatural erosion caused by impervious surfaces and development. It allows you to implement LID facilities into stormwater design seamlessly and to prepare for the future challenges that will come with the advancements in population and the more control of the water resources that are crucial to manage. And so what are the repercussions of not changing how we're going to be doing water resources engineering? Well, the continuation of the old methods will not prepare communities for the changing water management challenges of the future. Also, not prepare engineers to model these challenges using efficient methods. They'll continue to be using old methods, take a long time for us to adapt and change and start using the new ones. And it'll cause environmental and economic damage because the more pollution in these streams, the harder it is to use the water, and then the more limited the water resources are. It becomes very damaging because prices rise because it's tough to use water and living conditions become difficult. It also damages the environment because the wildlife are not accustomed to this amount of erosion and pollution in the streams. And so to preserve the environment and also the economics of the region, it is important to use these methods. So what are some of my final thoughts? Well, we do have quite a few challenges when it comes to water resources management coming in the future, but there are ways to easily mitigate these challenges and start implementing continuous simulation modeling and models that are able to account for these erosive flows to help better the community. And we need to leave these old methods on the wayside because they're simply not going to be feasible in the future. No matter how much we continue to use them in the present, they're just not going to work and be able to keep up with the challenges that we will have in the coming years. So thank you for watching this video. You can see other videos on the Clear Creek Solutions YouTube channel, and I'll see you guys next time.